Welcome to the video where we're going to work on the example with the parameter t, and we are asked to find the highest point, leftmost point, and also horizontal and vertical asymptotes. So seems like since we are asked to find the highest point and leftmost point, we will need to check both derivatives of x and derivatives of y with respect to t. So let's just find those. The derivative of x with respect to t will be a product rule, as you can see, 7t times e to the t, or just t times e to the t, the way you like it, you do it yourself. Derivative of 7t is just 7, copy e to the t, plus copy 7t, derivative of e to the t is e to the t. Derivative of y with respect to the parameter t is going to be product rule as well. Derivative of 5t is just 5, copy e to the minus t, copy 5t, derivative of e to the minus t is e to the minus t times minus 1. These are important, so I'll put them in the box. Each, that's the derivative of the corresponding variable with respect to t. Now, the highest point on the curve will occur at the horizontal tangent. You can imagine this way: if you're working with a circle or maybe even a flower, whatever you want to see, what is the highest point of that flower? It is going to be where you have a horizontal tangent line. So to find where the line is horizontal, you need to make sure that your dy does not, that your y doesn't change, right? So y is a constant, it's fixed, right? Y does not change. But x can be changing because x is running left and right, so x is changing. Y is not changing. How to mathematically write down the fact that y is not changing? That means derivative of y with respect to t is 0, but derivative of x with respect to t is not 0. So that's going to be our question number 1. Question number 1 is about highest point. Highest point occurs at the horizontal tangent. Horizontal tangent, on the other hand, occurs when outputs dy over the output does not change. The derivative of y is 0, but inputs do change. So derivative of the input function is not 0. Well, we found the derivatives, so let's check. The dy over dt, dy over dt is 5e to the minus t, that's equation number 2, minus t, should be 0. So let's solve it. Well, let's factor out 5e to the minus t, and I will have 1 minus t left equals 0. For you to understand, exponential function is not 0, right? You remember that? 5 is not 0 as well, so that whole thing is not 0. So I have one solution here, t is 1. But I also need to check that this solution does not make derivative of x 0. So I'm gonna check that, and I can just make a claim if I want to, that if I plug t equals 1 into the derivative of x, so this is the notation, derivative of x with respect to t at t equals 1. It's going to be 7e plus 7e, which is not 0. So that's good. So we found where the derivative of y is 0, the derivative of x is not 0, and that is when t is 1. That is not the final answer. They want us to answer in the form of x comma y. So t equals 1, plug or substitute into x and y. I will have x equals y equals, going back, x is 7t e to the t. So it's going to be 7e, right? Y is 5t e to the minus t. So it's going to be 5e to the minus 1. Then the answer will look like this. T equals 1 gives me a pair x comma y, which is 7e 5e minus 1. And this is where the highest point occur, where the horizontal tangent line is. Now the leftist point, B, left, not leftist, apparently you have to say leftmost point, happens on the curve where at the vertical tangent line, at a vertical tangent. Same, if you imagine the same flower, where is your leftist point? Leftmost point over here. This is the horizontal tangent, this is the vertical tangent. And how to describe mathematically vertical tangent? So now seems like input x is fixed. How to figure that out? It means the derivative. So x is now fixed. So let's call this one fixed as well to be consistent. Fixed. But height y is changing. And now you can imagine how I will describe it using derivatives. That means I want to say, let's be consistent with colors, black colors, blue colors. That means I will say that now x is fixed, so derivative of x with respect to t is 0. But derivative of y is not 0 because height is changing, and that's what gives me vertical tangent. Let's take the derivative of x and solve for t. Derivative of x is the first equation, 7e to the t plus 7te to the t. 7e to the t plus 7te to the t equals to 0. Factor out 7e to the t, gives me 1 plus 7, gives me 1 plus t equals to 0. Same idea, the first factor is never 0, but t equals minus 1 makes derivative 0. And also I can check that dy over dt at t equals minus 1 should not be 0. So I'm plugging into the equation number 2 to check what's going to happen. 5e to the minus t becomes 5e to plus 1, right? Because t is minus 1. Minus 5t becomes plus 5. Plus 5. And e, I think to the minus, no, and just e. That is not 0. That's important. So check marks. The derivative of x is 0. The derivative of y is not 0. And the solution we found is t equals minus 1. And just like we did before, we're going to plug this using red color to be consistent. T equals minus 1 gives me x and y. Plugging x and y. If I plug x, it gives me minus 7e to the minus 1. And then y will be minus 5e, check. Then the answer will be at t equals minus 1, I will have a pair x comma y, which is at the point minus 7e to the minus 1 minus 5e. That is the answer. At this point we can see there's a vertical tangent. Okay, last question, C. We're asked to find vertical asymptote and horizontal asymptote. Let me start with horizontal asymptote. Well, these are very interesting. So horizontal asymptote, if just imagine any kind of graph, if you don't understand what is going on, if you don't remember first calculus, imagine that horizontal asymptote looks something like this. So if you want to see if a function has horizontal asymptote, you want to check the behavior of the function when input is infinite, both at left side and the right side. So check when x goes, not in this case, input is t. T goes to plus and minus infinity. So let's check that. What happens when t goes to plus infinity? Then, if the answer is infinity, then there's no asymptote, right? But if the answer is a number, then we can say that indeed, even though, so x goes to infinity, but y stacks at some number, that indicates horizontal asymptote. And it's exactly what happens. So if you don't remember, we're working, let me write down the functions for you to make sure you remember the original functions. So x is 7t e to the t. Y is 5t e to the minus t. Let's see what's gonna happen. At plus infinity, x blows up. X blows up to plus infinity. Let me write down plus infinity, right? So t goes to plus infinity and e to the t goes to plus infinity. So that means it means x goes to the right when t goes to the right. That's the idea. Let's see what happens with y. If y goes to plus infinity, there is no asymptote. But y actually shrinks to 0 because of this piece. So t blows up to plus infinity, that's true. But e to the minus t shrinks to 0. And now do you know who is faster? You can check L'Hopital's rule here, or you just know the speeds of functions. You can check my video on that. Speeds of functions. Exponential function shrinks to 0 faster than t blows up to infinity. So I will write down that y goes to 0. Since y goes to 0, the most important is not a number. It's important that 0 is a number. This is a number. So when x blows out to infinity, y shrinks to a number, some kind of number. That indicates a horizontal asymptote. So we have horizontal asymptote here. Now what happens on the left-hand side? Very interesting. When t goes to minus infinity, let's see on the left. Then it seems like everything switches. Now, let's start with y. Let's see what's gonna happen. Y used to shrink to 0 because of minus t. E to the minus t can be written as 1 over e to the t. So when t goes to plus infinity, you're actually dividing by huge numbers, which makes it 0. However, if t goes to minus infinity, minus makes it plus. So now this actually blows up to plus infinity, because minus infinity is plus infinity, and e to raised to the plus infinity is plus infinity. So y now blows up to infinity, plus infinity. That means y is going up forever. If x blows up as well, there is no horizontal asymptote. But x actually shrinks to 0. X shrinks to 0 because now exactly the same story happens which we had with y before. E to the minus infinity. Now we have that. We have e to the minus infinity because t now goes to minus infinity. So x shrinks to 0. And because 0 is a number, then we can say y blows up forever, goes up forever. The situation looks like this, if you don't remember. Always draw a picture. A vertical asymptote is like this. Y blows up forever while x stacks at some kind of number. That's what's happening. And in this case, it's 0. So we are looking at vertical asymptote. So the answer is, let me write down the nice answer. We observed that there is horizontal asymptote at y equals 0 and vertical asymptote at x equals 0. Since vertical asymptote is vertical, that's about x location. Horizontal asymptote is horizontal, so it's about height, y location. And we completed the problem. So it's very interesting that t, time, or whatever t parameter means, is not on any of these graphs. It's like a third dimension we don't see. But while t is changing, x and y are changing. So because of that, x can blow up and y can blow up depending on how far t goes. And that's how you can determine vertical horizontal asymptote. Pretty cool problem and pretty cool ideas. Hopefully you understood that. And have fun with more problems like this. See you next time.